A simple introduction to scientific notation. So, what is scientific notation? Well, scientific notation is a way to write very large or very small numbers in a compact form. It makes working with these numbers quicker and easier, and is widely used in fields such as chemistry, physics, and astronomy. The numbers are represented like this: a times 10 to the power of n. Let's also have a look at a quick example to understand why writing numbers in scientific notation could be useful to us. For instance, the precise distance between the Sun and the Earth is 149,600,000 kilometers. And this is a pretty big number, and it takes a while to write, so to make it easier for ourselves, we just convert it into scientific notation, and it becomes 1.496 times 10 to the power of 8 kilometers. And this is easier to write and just easier to work with. So let's figure out how we can do these conversions ourselves. It's actually pretty simple. There are two straightforward steps that we need to follow. The first is to move the decimal point so that the number becomes a value between 1 and 10. And the second is to count how many places the decimal point moved and to determine if the exponent is positive or negative depending on which direction it moved in. Let's do this through an example. We have the number 450,000, and we need to convert it into scientific notation. Where do we start? Well, we start off with our decimal point here, and we need to move it so the number becomes a value between 1 and 10. So we move it like this: 1, 2, 3, 4, 5. So we moved it 5 steps, and our new value is 4.5, so that's between 1 and 10. And we can also see that we moved the decimal point to the left, and this means the exponent is going to be positive. So let's rewrite it as 4.5 times 10 to the power of positive 5. Let's have a look at some practice questions. Feel free to pause the video and try these out for yourself. So same thing here. We start off with our decimal point and we just move it. 1, 2, 3, 4, 5, 6, 7, 8. So 8 steps, and we move to the left, meaning the exponent is positive. So 7.807049 times 10 to the power of positive 8. Same thing here, we just move our decimal place. So 1, 2, 3, 4, 5, 6. So 6 here. And our new number is 3.25 times 10. And we can see that actually here we moved to the right. So that means our exponent is negative, so negative 6. Same thing here, 1, 2, so 2 steps, and to the right, so a negative exponent, so negative 7.65 times 10 to the power of negative 2. And this is the last question here, and we can actually see that the value is already between 1 and 10, so we don't need to change the number itself. So we can just rewrite it as 9.0874 times 10 to the power of 0 because we moved the decimal point 0 times. But it's also useful to know how to convert in the opposite direction, so from scientific notation to decimal form. Again, it's pretty simple. We just need to look at our exponent. So if we have a positive exponent, that means we need to enlarge the number. And if we have a negative exponent, it means we need to reduce the number. And when we do this, we'll create empty spaces, and we need to fill this in with zeros. Let's have a look at an example. So 4.5 times 10 to the power of 3. So we can see we have a positive exponent, meaning we need to enlarge the number. So 4.5, and we move the decimal point to the right, so 1, 2, 3. And our new number is 4,500. Let's have a look at some practice questions. Feel free again to pause the video and try these out for yourself. So the first question here, we have a positive exponent, so we need to make the number bigger, 8.627, and then to the right, 1, 2, 3, 4, 5, 6. Here we are. Same thing here. We have a negative exponent though, so we need to make the number smaller. 9.91, 1, 2, 3, 4. And let's put the 0 here in front. 1, 2, 3, 4. Here we have the exponent and it equals 0. So that means we don't need to do anything to the number and we just rewrite it. So 2.11. And here we have a negative exponent, but also a negative number. But to start off, let's just forget about the negative and rewrite the number. So 1.23, and then 5 steps. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And let's add the negative. So now that we know how to convert between the two forms, let's try to do an application question. And there's just some new information that we need for this question, and it is up here. And it has to do with how to multiply numbers in scientific notation. So it's really just multiplying the coefficients and adding the exponents. So if you want to try this question for yourself, just pause the video and do that. Otherwise, we're going to do it together now. So a red blood cell weighs 2.7 times 10 to the power of negative 12 kilograms. If there are 1 million red blood cells in a blood sample, what is the total weight of the red blood cells in scientific notation? So let's start off by just writing the numbers that we need. So here, 2.7 times 10 to the power of negative 12. And then we also have 1 million here. So let's rewrite that as a number. So 1 million. The first step is to make sure that both of these are in the same form. So let's convert the 1 million into scientific notation. And we know how to do this. We just have our decimal point here and we move it. 1, 2, 3, 4, 5, 6. So 6 steps. And this then becomes 1 times 10 to the power of 6. So now we have both of these in scientific notation, and we just need to multiply them. So let's rewrite it. 2.7 times 10 to the power of negative 12 times 1 times 10 to the power of 6. So let's multiply the coefficients. So 2.7 times 1 is just 2.7. And then the tens, so times 10. And now we need to add the exponents. So negative 12 plus 6, like this. And the last step is to just do this little question up here in the parentheses. So 2.7 times 10 to the power of negative 6. And let's not forget the units, kilograms. And that is our final answer. Thank you so much for watching. If you enjoyed the video, please like it and subscribe. Bye!